Have you ever gazed up at an airplane soaring through the sky and wondered, how is that even possible? The answer lies in a delicate dance between four fundamental forces: lift, thrust, gravity, and drag. These forces, working in perfect harmony, are the invisible strings that make flight a reality. Lift is the upward force that counteracts gravity, the force pulling everything towards the earth. Imagine holding a kite on a windy day, the wind pushing against the kite, lifting it higher. That's similar to how lift works for airplanes. Thrust, the forward force, propels the airplane through the air, like a boat's engine pushing it through water. Drag, on the other hand, is the resistance an airplane faces from the air itself. Think about running your hand through water. The resistance you feel is similar to drag. Lastly, gravity, the constant companion of everything on Earth, tries to pull the airplane back down. The magic of flight happens when lift overcomes gravity, and thrust overcomes drag. This careful balance, achieved through ingenious engineering and design, allows airplanes to grace the skies and transport us across continents. The wings of an airplane are its most crucial component, the very reason it can defy gravity and achieve flight. Their unique shape, known as an airfoil, is the key. Picture a teardrop sliced in half lengthwise. That's the basic shape of an airfoil. The upper surface is curved while the lower surface is relatively flat. As the airplane moves forward, air flows over and under the wings. The curved upper surface forces the air to travel a longer distance, thus faster, compared to the air flowing under the wing. This difference in speed creates a difference in air pressure. The faster-moving air above the wing creates an area of low pressure, while the slower air below creates an area of high pressure. This pressure difference generates lift, an upward force that pushes the wing, and thus the airplane, skyward. The genius of the airfoil design is its simplicity and effectiveness in harnessing a fundamental principle of physics, Bernoulli's principle, to achieve flight. While wings provide the lift needed to overcome gravity, engines provide the thrust, the driving force that propels the airplane forward. Think of the engines as the heart of the airplane, pumping energy into its wings. There are primarily two types of engines used in airplanes: jet engines and propeller engines. Jet engines, marvels of modern engineering, work by sucking in air, compressing it, mixing it with fuel, and igniting the mixture. This combustion process produces hot, expanding gases that are expelled out the back of the engine at high speed, creating thrust. It's like blowing up a balloon and letting it go. The escaping air propels the balloon forward. Propeller engines, on the other hand, use rotating blades to push air backward, just like a fan. This backward push of air creates an equal and opposite reaction, pushing the airplane forward, following Newton's third law of motion. Whether it's the roar of a jet engine or the whirl of a propeller, these powerhouses are essential for achieving and maintaining flight. While the wings and engines get most of the glory, the tail of an airplane plays a crucial role in maintaining stability and control. Think of it as the rudder of a ship, keeping the airplane steady and pointing in the right direction. The tail consists of two main parts: the horizontal stabilizer and the vertical stabilizer. The horizontal stabilizer, resembling a smaller wing positioned at the rear, prevents the airplane from pitching up and down uncontrollably. Imagine a seesaw. The horizontal stabilizer acts as the balance point, keeping the nose of the airplane from dipping or rising too sharply. The vertical stabilizer, the upright section of the tail, prevents the airplane from yawing or swinging from side to side. It acts like a fin, keeping the airplane pointed straight ahead. The tail, often overlooked, is essential for a smooth and controlled flight. Section 5. Flight Control, a pilot's symphony of movement. Flying an airplane is like conducting an orchestra, with the pilot acting as the conductor, expertly manipulating various controls to achieve the desired outcome. These controls, known as control surfaces, are primarily located on the wings and tail and allow the pilot to adjust the airplane's orientation and altitude. The ailerons, located on the trailing edge of the wings, control the airplane's roll, or its movement around its longitudinal axis. Imagine tilting a bowl from side to side. That's roll. Moving the control stick left or right causes one aileron to move up and the other to move down, creating a difference in lift that rolls the airplane. The elevators, located on the horizontal stabilizer, control the airplane's pitch, or its up and down movement. Pulling back on the control stick raises the elevators, increasing lift and pitching the nose up. Pushing forward lowers the elevator's decreasing lift and pitching the nose down. These control surfaces, responding to the pilot's touch, allow for precise maneuvers in the air. Section 6. Takeoff, leaving the ground behind. Takeoff is the most exhilarating part of any flight, the moment when a massive machine defies gravity and takes to the skies. It's a carefully choreographed sequence of events, a testament to the power of engineering and the skill of the pilot. As the airplane accelerates down the runway, the engines roar to life, generating thrust and pushing the airplane forward. The pilot, feeling the increasing speed, carefully manipulates the control surfaces. As the airplane gains speed, air flows faster over the wings, generating lift. The pilot, sensing the lift exceeding the airplane's weight, gently pulls back on the control stick, raising the elevators and pitching the nose upward. The airplane, now freed from the grip of gravity, begins its ascent, climbing higher and higher into the sky. Section 7. Cruising altitude, soaring among the clouds. Once the airplane reaches its desired altitude, it enters the cruise phase, a period of relatively stable flight where the focus shifts to maintaining altitude and navigating towards the destination. Think of it as the calm after the storm, a time to sit back, relax, and enjoy the view. During cruise, the four forces of flight are in equilibrium. The lift generated by the wings equals the weight of the airplane, preventing it from climbing further or descending. The thrust produced by the engines counteracts the drag created by the air, allowing the airplane to maintain a constant speed. The pilot, like a vigilant captain, constantly monitors the instruments, making minor adjustments to the control surfaces and engine power to ensure a smooth and level flight. Section 8. Turning, navigating the skies with grace. Turning an airplane is more than just moving the control stick left or right. It's a coordinated effort, a graceful ballet in the sky that involves banking the airplane and using the rudder to maintain balance. To initiate a turn, the pilot uses the ailerons to roll the airplane in the desired direction. For example, to turn right, the pilot moves the control stick to the right, causing the right aileron to move up and the left aileron to move down. This creates more lift on the left wing and less lift on the right wing, causing the airplane to bank or tilt to the right. As the airplane banks, the lift force, which normally acts straight up, is now angled, providing a component of lift that pulls the airplane into the turn. The pilot uses the rudder, controlled by pedals on the floor, to coordinate the turn, preventing the airplane from slipping sideways. Section 9. Landing, returning to Earth gently. Landing an airplane is often considered the most challenging aspect of flight, requiring precision, timing, and a delicate touch from the pilot. It's a carefully controlled descent, a gradual return to Earth that culminates in a smooth touchdown. As the airplane approaches its destination, the pilot initiates the descent by reducing engine power and adjusting the airplane's pitch to a slightly nose-down attitude. Flaps, extendable panels on the wings, are deployed to increase lift and drag, allowing the airplane to descend at a controlled speed. As the airplane nears the runway, the pilot further adjusts the pitch and engine power to fine-tune the descent rate and align the airplane with the runway centerline. With a gentle flare, raising the airplane's nose slightly just before touchdown, the pilot ensures a smooth and controlled landing.